Let me ask you something before we begin. If science has progressed so far, if we can detect gravitational waves, image black holes, and send probes beyond the solar system, why do so many fundamental questions about the universe remain unanswered? Science is often presented as a collection of facts. Textbooks, documentaries, and headlines make it seem as though humanity already understands most of reality. But the deeper scientists look, the clearer something becomes. The universe still holds enormous mysteries. In fact, some of the most important questions in physics and cosmology remain completely unsolved. One of the biggest mysteries is something called dark matter. When astronomers observe galaxies, they notice something strange. Stars at the outer edges of galaxies move much faster than expected. According to the laws of gravity, those stars should fly away into space. But they don't. Something invisible is holding galaxies together. Scientists believe there must be an enormous amount of matter we cannot see. This invisible mass does not emit light, does not reflect light, and barely interacts with normal matter. Yet it exerts gravity. Today, physicists estimate that about 85% of the matter in the universe is dark matter. Despite decades of experiments, no one has directly detected what dark matter actually is. Even stranger is something called dark energy. In the late 1990s, astronomers discovered that the universe is not just expanding, it is expanding faster and faster. Something is pushing space itself outward. This mysterious force has been called dark energy. Today we believe dark energy makes up about 70% of the entire universe. But scientists still do not know what it is. Some think it could be a property of empty space itself. Others believe it might indicate that our understanding of gravity is incomplete. Another mystery lies in the nature of time. We experience time as something that moves forward. The past is behind us, the future is ahead. But the fundamental equations of physics do not require time to flow in one direction. In many of the deepest theories, time does not behave the way we experience it. Some physicists even suggest that time may not be fundamental at all. Instead, it might emerge from deeper physical processes, much like temperature emerges from the motion of molecules. Quantum mechanics introduces another mystery that scientists still debate today. At the quantum level, particles behave in ways that defy classical intuition. A particle can exist in multiple states at once, a phenomenon known as superposition. But when we measure the particle, it appears in only one state. Why does measurement cause this change? What actually happens during observation? This is known as the measurement problem, and even after nearly a century of research, there is no single agreed upon explanation. Then there are black holes, some of the most extreme objects in the universe. According to physics, black holes slowly evaporate through a process called Hawking radiation. But if a black hole eventually disappears, what happens to the information about everything that fell into it? Quantum mechanics says information cannot be destroyed. Yet black hole evaporation seems to erase it. This conflict between quantum theory and gravity is known as the black hole information paradox, and solving it may require an entirely new theory of physics. Even the origin of the universe remains mysterious. Cosmologists believe the universe began about 13.8 billion years ago in an event known as the Big Bang. But what caused the Big Bang? What existed before it? Some theories suggest our universe may have emerged from quantum fluctuations. Others propose that our universe could be one of many in a larger multiverse. At the moment, no one knows which of these possibilities, if any, is correct. There is also a deeper question that may be the most difficult of all. Why do the laws of physics exist at all? The universe follows mathematical rules with astonishing precision. Gravity behaves consistently. Quantum mechanics predicts outcomes with incredible accuracy. But why do these laws exist? Why are they the way they are? Could they have been different? Science can describe how these laws work, but explaining why they exist is far more difficult. All of these mysteries reveal something important about science. Science is not a finished story. It is a process of discovery. Every answer opens the door to new questions. Every experiment pushes the boundaries of what we understand. In fact, the most exciting moments in science often occur when our theories fail to fully explain observations. When measurements don't match predictions, it forces scientists to rethink their models of reality. That is how revolutions in physics begin. Newton's laws once seemed complete until Einstein discovered relativity. Classical physics once seemed sufficient until quantum mechanics emerged. The next great scientific breakthrough may be waiting inside one of the mysteries we discussed today. What makes this moment in history remarkable is that we are living at a time when many of these questions are actively being explored. New telescopes are mapping the universe with unprecedented precision. Particle accelerators are probing deeper into the structure of matter. Gravitational wave detectors are listening to the collisions of black holes billions of light years away. With every new observation, humanity learns something about the universe. But the more we learn, the more we realize how much remains unknown. And perhaps that is the most powerful aspect of science. Not that it provides final answers, but that it continually expands our understanding of reality. The universe is vast, complex, mysterious, and the journey to understand it has only just begun. Still, within